あと All right, hello everyone. Good to see you all here. Got 5 people in, same thing. We're gonna wait 5 minutes and then we're gonna get started. All right. Hello Camilla, good to see you. Good afternoon, Russell. Good afternoon, Treyu, Mac, John, Chris. Good to see you all. Hello, Alexandra. Hello, Amir. Hopefully you guys have already printed out section 4.1. If you haven't, please take the time to do so. No, we are not using Discord. I'm not switching the platform. We are sticking with YouTube. So another 3 more minutes and then we'll get started. We'll start at 1:05. We're gonna start 1:05 right on time. And then once we finish that, or once that time hits, we'll start, and then we'll see how long today's class takes. I have a feeling it might end a little early, but I'm not too sure. Alright, how many people do we have watching right now? We got 7. Where's half our class? Where's the second half of our class? Our half of our class is gone. Usually, I remember most people were okay with Mondays. There was no issues. That's weird. Okay, let's get started. Okay, so please take out your 4.1 and then we'll continue on with that. So 4.1 should look like this. Okay, so we're working with recognizing linear relations. So this is what you should have opened up. We're going to go over kind of the first 2 pages. The 3rd page will be for your own, and then we have homework as well. Okay? So, it should be a relatively short session. Okay? Relatively short session. And then we'll kind of continue on from there. Okay? A quick announcement for those that are just tuning in. As well as you came in at a good time. Big thing that I want you to understand is that although the test assignment is due today, please hand it in. The deadline was only set today because I don't want you to use, I don't want you to continue to work on the test assignment while we start a new unit, or else it's going to be too much work for you at once. But I will still accept late assignments. It's not going to get marked off or deducted marks. But please take your time in doing it. Hand it in when you can if you haven't handed it in yet. There's no pressure on time, but it will become harder the longer you wait to do it because I'm going to be assigning more things for you to complete. Okay, so please keep that in mind as we continue to work on this stuff here. Okay, so 4.1, recognizing linear relations. First difference is, so it says here, for a table of values in which x values increase by a constant amount, okay, you can calculate the first differences by subtracting the values of y. So we call a relation linear if the points lie on a straight line. So we talked about that last unit. A relation is linear if the x values increase by the same amount and the y values increase by the same amount, okay? I will usually try to make the x values increase by the set amounts so that it's not like there's no trick question. A relation is linear if the first differences are constant, and this is in bold because this is important. Okay, and we're going to talk about that. Okay, so before you even graph anything, you can tell that something is perfectly linear, right, through the first difference. So let's take a look at our first example here. Okay, so our first difference here, okay, this is our first difference here. We have 1, 2, 3, 4, 5, 3, 7, 11, 15, 19. So to calculate the first difference, it's going to be a little weird. You'll notice that the boxes in between these two boxes here, okay, we're going to take the second number in the y and subtract it with the first number. So we're going to take 7 and then we're going to subtract 3. Okay, so let me zoom in so you can see that a little better here. Okay, so we're going to take 7 and then we're going to subtract 3. And then that will give us our first difference. So that's going to give us 4. For the second row, we're going to take 11 and subtract 7. So we're always taking the bottom number and subtracting it with the one on top. So we're going to take 11 and then subtract 7. That's going to give me 4. Then we keep going. 15 subtract 11 is 4. And 19 subtract 15 is 4. And you'll notice all the first differences are the same. All the first differences are 4. So therefore, this relation must be linear. And so that's how you do it. Very simple, just like that. Let me zoom out just a little bit so I can fit the second one here. So let's go to the second one while keeping our first one as a reference. We have here 36 and 49. So 36 is going to go first. Notice how it doesn't have to be the bigger number. It's always the number on the bottom. Okay? So 36 minus 49 is equal to, okay, negative 13. So we have negative 13 here. Then the next one here, 25 minus 36 is negative 11. Oh. They don't match. You actually don't need to do the rest. Okay? You don't need to do these two here. But you can. But if they don't match already, you already know it's nonlinear. So you can actually just write the answer already, nonlinear. And that would be full marks. Now if you were to continue going, just so that you get practice. Do you have to put brackets? Yes, and you'll see why in the next one. Okay, so we have all of these here. You'll see none of them match. They're not constant, so it's nonlinear. Okay, so we'll move to our last one here. Okay, first difference. We have here 2 subtract 5. So 2 subtract 5 is going to be -3. Then we have here the -1. So to answer Chris's question, we put brackets because you'll see that you don't want to mess up the negative. This subtraction sign is already there. It's not a negative sign. So we're making sure it's separate. Okay? And I think that's what Russell said in chat. Yes, he did. Very good. So if we continue on here, -4 minus -1, notice how the two negatives are there, but the -1 is in its own bracket. That way, negative times a negative is a positive. So this is still going to give us -3. And the last one, -7 minus -4, is also going to give me -3. Okay? So this, in total, okay, is going to be linear. So they're all -3s. The first difference is constant, so this must be linear. Okay, so hopefully that made sense and it's easy to understand. First difference calculations. Okay, so what I want you to do now is on your own. You have here 2 problems here. For Vanessa and Ali, can you calculate the first difference for each of them? Okay. Calculate the first difference of each of them and tell me, is it linear or non-linear? I'm going to give you around 5 minutes to do that. So I'm going to give you 5 minutes. Please figure out the... Oh, actually, I'm going to give you 4. I think 5 minutes is a little long. So 4 minutes. Calculate the first difference for Vanessa and Ali and tell me, is it linear or non-linear? Go for it. Good luck. All right, I just realized I did not unmute myself. Whoops, that's embarrassing. Okay, so let's check your numbers here. Your first differences that you should have gotten for each one. I'm just going to write it on the side here so you don't miss anything. It's all 90 for this one here. Which means for Vanessa, she's linear. And then for Ali, you should have gotten 60. 50. Oh, sorry, it's not 50, 70. Sorry, I did the math wrong in my head. 70, 80, 90, 100. Okay, so that's what you should have gotten here, and this would be non-linear. Okay, so if I were to show our work here, okay, should be 90 minus 0, 180 minus 90, 270 minus 180, 360 minus 270, 450 minus 360. So those are our values there. For our right side here, we have 60 minus 0, 130 minus 60, 210 minus 130, 300 minus 210, and then 400 minus 300. Okay, so we have our values here. Now, if I ask you who do you think will win the race? Okay, who do you think will win the race? Type V for Vanessa and A for Ali in the chat. Who do you think will win the race? V for Vanessa, A for Ali. Who will win? Seeing a lot of V's, or well, only V's. Give it another 5, 4, 3, 2, 1, 0. Fantastic. Everyone's wrong. It's Ali. It's not Vanessa. Now, why do you think it's not Vanessa? Why is it Ali? Ali's the one that's going to win the race. Absolutely. There's no doubt about it. Looking at our chart here, Ali's going to win the race. Now let's think about that for a second. What does the first difference mean here? Well, we're subtracting distance, right? We're subtracting her distance from 30 seconds before, and so on and so forth. If that's the case, right? If that's the case, then it's because the differences are increasing, Ali's getting faster. Vanessa is staying at the same speed. Ali is getting faster, which means on the next one she should be 110, then 120, 130. She's going to overtake Vanessa. Remember, the run or the race is 1 kilometer. They're only halfway, which means Vanessa's going to win. Ali's getting faster. Right? She's accelerating. She's going faster. Okay? So there's our reasoning here. So hopefully you got the first differences correctly. Let's move on to the second page here. Right? We're going to do this first page together, and then the second page will be for homework. Okay? So first page here. Jody works at a factory, produces square tiles for bathrooms and kitchens. She helps determine shipping costs by calculating the perimeter of each tile. Okay, simple stuff. If it's one side, remember a square is 4 equal sides. So if it's 1 centimeter, then the total perimeter is 4, right? Because there's 4 sides. If the side length is 2, then the perimeter must be 8. And this side length is 3, perimeter is 12, 16, 20. So that's pretty straightforward. Filling in the chart is simple. We calculate the first differences. 8 minus 4 is 4. 12 minus 8 is 4. 16 minus 12 is 4. And 20 minus 16 is 4. So there we go. Okay. So there's our first differences. So we know from looking at the first differences, this is most definitely linear. Right? This is linear. It has to be. The first differences are all the same. So let's go to part 2, which is describe what happens to the perimeter of each tile when the side length increases by 1 centimeter. This is the relationship. Describe the relationship. That's what it's asking you to do. That's what it means. So we're describing the relationship. So the perimeter of each tile increases by how many centimeters? How many centimeters does the perimeter increase by? Four, exactly. Increases by 4 centimeters when the side length increases by 1 centimeter. Okay. So there's our full answer. The perimeter of each tile increases by 4 centimeters when the side length increases by 1 centimeter. Okay. So there we have it. Then part 3, construct the graph. So we have to make a graph now. So this was just our last unit, right? Now you're understanding, oh, we did all this freaking graphing because we're gonna do it in this one using linear relations. We need to know how to graph. This is important. So this is what I'm expecting you to do because we've already done it before. So we're gonna construct a graph. We need to include labels, titles, so perimeter versus side length. So we're gonna write that at the top there. Y versus X. And then what variable is the independent variable? Well, the independent variable is our X variable, and our X is always the one on the left. So side length is our independent. That means our dependent is perimeter. Okay, so let's graph it. Okay. So let's label everything first. So let's do side length here. That's our independent. In centimeters, we have our units. Perimeter is here. I'm going to turn it sideways so I can write perimeter. Okay. So we have our perimeter there. And now for our side length, well, we can space it out. 1, 2, 3, 4, 5. Notice how that's spaced out. Every 2 squares is going up by 1. For my perimeter, I can go 4, 8, 12, 16, 20. And then that's going to give me my beautiful graph. And we should see a perfectly straight graph, right? Essentially, it's 2, 4, 6, 8, right? Going up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we're going up by 2s, and if I graph it perfectly, we have our graph there. Okay, it should be a perfectly straight line, as we should expect, because we said it was linear earlier. We already described the relationship in part 2, so that's going to be skipped. Okay, let me zoom out. I think it's still zoomed in. Yeah. So we already described the relationship, right? That was part 2. This is the relationship. So let's describe the shape of the graph. Well, what's the trend? If we were to describe using the three words for trend, strong or positive or negative, strong or weak, linear or non-linear. So first one would be positive. It's going up. It's strong. And it's linear. Okay? Simple enough. So notice how everything we've learned last unit is now coming into play for this one. And we're going to add on even more for this unit. Okay? So we calculated the first differences. They're all the same. The first differences are the same. And then summarize your observation. So when the side length increases by 1 centimeter, the perimeter increases by 4. A plotted point suggests a linear trend. And the first differences are constant, or in other words, the same. Okay? So there's our work for this page here. Let me zoom out so you can see a little better about what we just did here. So page 3, that is complete there. Let me freeze that there. So your homework, and if you choose to hand in this homework, you can hand in this homework. Okay? So this is page 3. Page 4 looks like this. Okay? You'll notice page 4 is exactly the same or almost identical to page 3. So please complete page 4. After this class is over, you're gonna see an assignment posted. This is not mandatory, but if you complete this homework, I will increase your mark. Okay? I will increase your mark for your math mark for the course, of course. Okay? So complete this and hand it in for homework. Take a picture of it, so on and so forth. And I will mark it, and then we're good there. So it'll be out of 10, and depending on how much work you've done, I'll give you a mark out of 10. Okay? There's gonna be no due date. You finish it. If you finish it, you hand it in, and then we're good to go. Okay? So that being said, that's page 4 homework. And that is our class for today. Okay? If you have any questions, please let me know. Message me, contact me, email me, use Google Classroom, do whatever you need to. But otherwise, that's our class for today. We're going to take up we're going to work on page 9 tomorrow. Okay? Oh, sorry, not page 9. Why am I going over to page 9? I'm at page 5. So we're going to be doing page 5 and page 6 and 7, right, tomorrow. So that's going to be going over what we learned today in 4.1, and then we're going to go continue on with 4.2 tomorrow. All right? So that's the goal. Hope you all have a good rest of the day. Do the homework if you haven't, and please finish the test assignment. It's okay if it's late. Just finish it and hand it in so I can mark it and increase your mark if you've done better than what you did before the March break. All right? So otherwise, have yourselves a good one. Peace out.